Okay, so now as a last example, let's do this integral. So we want to integrate x squared minus 2xy plus y squared times e to the x plus y. And the region of integration now will be this type of trapezoid, if you want to call it that. So it goes through the points 0, 2, 2, 0, 1, 0, 0, 1. Okay? And again, part of what you need to learn how to do, like if the change of variables is not suggested to you, is to find what it should be. Here's one way to think about it. If you don't know if the equations of the curves are not given to you, the first thing you should do is to find them out. So what's the equation of this line? Well, this is the line y equals minus x plus 2. What is the green line is y equals minus x plus 1. What's the blue line? That's part of the line y equals 0. And what's the yellow line? That's part of the vertical axis, so that's x equals 0. So those are the four equations that you are trying to understand here. And so notice that the function itself, this term can be written as x minus y squared. So you have something with x minus y and something with x plus y, and that suggests making a change of variables, which is you say x plus y and b to be x minus y. Another reason why you want to make this change of variables is because you see, if you make this change of variables, this becomes y plus x equals 2 or u equals 2. So we already know here in the UV plane that one of the lines is u equals 2. One of the lines is u equals 2. In the for the green line, it's the same story. This is the same as saying y plus x equals 1, or u equals 1. So you get here u equals 1. And then x equals 0. Okay, x equals 0, y equals 0. We have to finish figuring that out. In order to figure that out, it's best to also know how to write x and y in terms of u and v. Again, to figure out where y equals 0 and x equals 0 map to, you have to find x and y in terms of u and v. If you add them together, you get u plus v equals 2x. So x equals u plus v over 2. And it's also not difficult to check that y, you just take the difference between them, and so you get that y equals u minus v over 2. Okay? So that was not too bad. But what that says is that y equals 0, the equation for y equals 0 becomes u minus v over 2 equals 0, which is, this can only happen when u equals v, and u equals v is the equation of like a straight line. And the other one, x equals 0, x equals 0, x equals 0 whenever u plus v equals 0. So this is the same as v equals minus u. And the equation for v equals minus u is something like this. So the region of integration is the stuff between 1 and 2 and between these two lines. So actually the region of integration is this. Okay? And so the integral becomes, we can use the order dv du if you prefer. So you would go from 1 to 2. V would go from negative u to u. This, remember, was x minus y. X minus y is v, so this becomes v squared. E to the x plus y becomes e to the u. And the only thing that's left to find is the Jacobian. Okay? But now for the Jacobian, what was the Jacobian? I think I'll do it here so that it doesn't interfere with the rest of the calculation. Remember, the Jacobian is the absolute value of the determinant of the partial derivatives of xu, yu, xb, yb. In this case, it's fairly simple matrix. Partial of x with respect to u is 1/2. Partial of y with respect to u is 1/2. Partial of x with respect to b is 1/2. Partial of y with respect to b is negative 1/2. So this determinant gives you minus 1/4, minus 1/4, and again it's in absolute values, so it becomes negative 1/2. In absolute values becomes 1/2. So really what you have to compute is just 1/2 of the integral from 1 to 2 negative u to u of d squared e to the u dv du. And I mean, this is a tedious thing to do, kind of. Not for v. Okay. It can be done, it's just kind of annoying because you have to do integration by parts. So, I mean, let's say that I change just because I'm lazy. It could be done. It's just, let's say that the function had been this. So that instead of e to the x plus y, you just get u. That's a lot faster. Otherwise, it would take us forever. Yeah. Now I like this one. Now this will be fast. So you integrate first with respect to v. So you get v cubed over 3. So you get 1 over 6. The integral from 1 to 2 of v cubed evaluated at u and negative u. Sorry, and times u du. And so that gives you u cubed minus u cubed, so that gives you 2u cubed. So that gives you 1/3 of 1 to 2 of u cubed times u du. And this is u to the 4. U to the 4 integrates to u to the 5 over 5. So you get 1 over 15 u to the 5 and 1 and 2. And this is 1 over 15 of 2 to the 5 is what? 32? 32 minus 1. And so you get 31 over 15. And that's the integral. So you see how much faster it becomes if you don't need to, if you make the right change of variables.